This is the third part of our lesson 8.3. We're going to prove a few theorems and do a little more challenging example in this video. Theorem 8.7 says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So the blue words are going to be our given. The red words are what we have to prove. So we are given that segment QR is congruent to segment, this is tough to see, SP. Also, that's top and bottom congruent. We also know that segment QP, that's the left side, has to be congruent to segment SR. That's the right side. The main goal, if you guys watched that first video, is to show that those two triangles are congruent. And you can do that pretty easily in this one because segment QS is congruent to segment SQ. That's itself by the reflexive property. Maybe you haven't done proofs in a while. Now, if you have two congruent triangles, that is going to make this a parallelogram. Maybe we'll just use our definition here. If you have congruent triangles, wouldn't those two alternate interior angles be congruent? I'm going to name it angle RQS. And I'm going to say that has to be congruent to angle PSQ. If your triangles are congruent, your corresponding parts are congruent. Likewise, let's put two arcs on these angles. I'm going to name that angle PQS. That's going to be congruent to angle RSQ. For the same reason, if the triangles are congruent, their corresponding parts are congruent. Now, when you have congruent alternate interior angles, that's going to make the top parallel to the bottom and the left side parallel to the right side. That's the converse of your alternate interior angle theorem. So this quadrilateral QRSP is a parallelogram because of the definition of parallelogram. You showed top and bottom were parallel and left side and right side were parallel. You're going to see an example like this on your assignment. What if you had a shape in a coordinate plane? Would you be able to show that it's a parallelogram? Sure you can. Remember how we did this before. You want to use slopes. So maybe I'll just make that note right here. The easiest way to show if two segments are parallel would be to count your slopes. So I'm going to go from A to B. It looks like I'm counting up 1 and over 1, 2, 3, 4, 5. Okay, so my slope there for segment AB would be rise 2, run 5. Now you got to do the same thing for the bottom side of the shape. That's segment CD. Let's find its slope. Again, I'm going to count. Maybe I'll use this purple here. Looks like I'm going down 2 and then 5 left. Okay, down 2 is -2, 5 left is -5. Are these slopes the same? Yeah. Segment AB is parallel to segment CD. You are halfway there to showing that this is a parallelogram. Now you got to do the same thing with the other side. So let's do that. I'm going to count from A to D. I'm going to go down 3, and it looks like I go to the right 3. So if I go down 3, right 3, I got -3 over +3. That's -1 over 1. Now I want to do the same thing from C to B. Looks like I'm going up 3. So my slope there will have a rise of 3. And I'm going left 3. So both of those slopes are -1/1. Segment AD is parallel to segment BC. When you get two pairs of parallel sides like that, this is a parallelogram. So use your slopes to do that. It's probably the easiest. Okay, let's look at one more proof. We're going to prove theorem 8.10. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Yeah, okay, good. So let's say our given is the blue. We're going to say that segment AE is congruent to segment CE. And segment DE is congruent to segment BE. That's your given. Remember, you want to show that you have triangles that are congruent. So I want to start by showing that triangle 1 and triangle 2 are congruent. Now I can do that because I know my vertical angles are congruent. That's angle AEB. That's congruent to angle CED. Now, since I use my vertical angle theorem, I'm also going to show that my other vertical angle pairs are congruent. That way I can show that we have two pairs of congruent triangles at the same time. So I'm going to say angle AED is congruent to angle CEB. So I can now just say that triangle 1 and triangle 2 are congruent, except I'm going to name them using 3 letters. So triangle AEB is congruent to triangle CED by side angle side. And you're going to do the same exact thing for the other triangles. We'll just call them triangle 3 and 4 just for simplicity. But you are going to name them with 3 letters there. So I'll call it triangle AED. It's congruent to triangle CEB for the same reason, side angle side. Now, if you want to show top and bottom are parallel, left side and right side are parallel, you can. But since we already have congruent triangles, doesn't that mean that segment AB and segment CD correspond? Those are corresponding parts of congruent triangles. Likewise, segment AD is congruent to segment CB for the same reason. Now, if you notice on your picture, that's the top and the bottom that are congruent, left side and right side that are congruent. So that means that this figure ABCD is a parallelogram. And then your reason is that theorem that we just proved earlier in a video, theorem 8.7.